Hi, this is AQA's practice paper set 3 for GCSE mathematics. This is the higher tier, and paper 2, which is the calculator paper. I'm going to go through each of the questions on this paper over the course of the next few videos. So let's get started with question 1 over here. Question 1 says the equation of a line is y is equal to 2x take away 1. And we just need to circle the point that is the intercept with the y-axis. Now, in order to intercept the y-axis, we would need our x-coordinate to be equal to 0, which means it's either going to be this one here or it's going to be this one here, because the x-coordinate is 0 in both of these. So these ones aren't intercepting the y-axis. Okay, and we need to check which of these is going to be the y-intercept for this equation. So this is saying the y-coordinate is equal to 2 times the x-coordinate take away 1. If my x-coordinate is 0, y is going to be 2 times 0 take away 1, which is just going to be negative 1. So it's not going to be this one here, and it must be this one here. Okay. Question 2 says simplify a to the power of 4 times a to the power of 6 over a cubed. So in order to simplify the numerator, I'm going to add those two powers together, so that's going to give me a to the power of 10, and I'm going to divide that by a cube, and then to do this division I'm going to subtract the powers, so that's 10 take away 3, which is a to the power of 7. It's going to be that one there. Okay, question 3 says a coin is thrown 50 times, the coin lands on heads 30 times. We want the relative frequency of it landing on heads. So the relative frequency is like an estimate of the probability, and it happens 30 times out of 50. So it's going to be 30 50ths. So 30 times it lands on heads out of 50 trials altogether. 30 50ths is going to be the same as 3/5. So it's going to be that one there. Okay, moving on to question 4. A number x is 15.8 when rounded to 3 significant figures. We want to circle the error interval. So when it's been rounded to 3 significant figures, it's going to be 15.8. So that means it's got to be between 15.75 and 15.85. So all of these show that. However, 15.75, if it was actually 15.75, it would round to 15.8. If it was 15.85, then it would round to 15.9. Okay, so this number would actually round to 15.9. So it can't actually be 15.85, but it can be 15.75. So it's got to be this one here, because in this inequality 15.75 is something it can be, whereas this part is what we call a strict inequality because it can't be 15.85. so this is showing what we want. Okay, question 5. Expand and simplify x plus 5 times x take away 4. A few ways that you can do this. You might use the FOIL method, or you might use a grid method. I'm going to use the grid method over here. Okay, so I've got x plus 5 times x take away 4. So x times x is x squared, x times negative 4 is negative 4x. That's going to be 5x there, and that's going to be negative 20. So I've got x squared take away 4x plus 5x take away 20. So that's one of my marks. And then if I simplify this, I've got x squared plus x take away 20. Similarly over here, I can do the same thing. We've got x take away 8, so I've got x and a negative 8 there, and x plus 7. X times x is x squared, x times 7 is 7x. negative 8x and negative 56. So we've got x squared plus 7x, take away 8x, take away 56, and then that's going to give me x squared, take away 1x, or take away x, take away 56. Okay. Question 6. Dev invests £1,500 for 2 years. The compound interest rate is 1.6% per year. So we want to decide which calculation works out the total value after 2 years. So we start with £1,500, and then the compound interest rate is 1.6%. So that means that it's going to increase by 1.6%. So 100%, if that went up by 1.6%, would become 101.6%. And as a decimal, that's going to be 1.016. Okay, so that there is going to be my multiplier to increase by 1.6%. Okay, so I know that I'm looking at one of these two over here. So if he invested £1,500 for 1 year, I would times it by 1.016. For the second year, I would have to times it by 1.016 again. So that's going to be this one here. 1,500 times by 1.016 times by 1.016, or 1.016 squared. Okay, part B says Emma invests £1,500 for 2 years. The interest rate is 1.8% for the first year, so that's going to be 101.8%, or 1.018, and then 1.3% for the second year, so that will be 101.3%, or 1.013 as a decimal. So we need to decide whose investment is worth more after 2 years, and we need to show our working out. Okay, so I need to calculate this here first. Okay, so that's going to be 1,500 times by 1.016 squared. And that gives me £1,548.38. So I've got 1,500 times by 1.016 squared, and that equals 1,548 £38.38. Okay, and then for Emma's investment, so that was for Dev down there. Okay, so for Emma's investment, so she again starts with £1,500, but now she's going to do this for the first year, so it's times by 1.018 for the first year, and then times by 1.013 for the second year. So this bit's increasing it by 1.8%, and this bit's increasing it by 1.3%. So if I now work that out using my calculator, I've got 1,500 times 1.018 times 1.013, and I've got £1,546.85. £6.85. Okay, so whose investment is going to be worth more after 2 years? And we can see that Dev's investment is going to be worth about £1.50 more than Emma's. So we can say Dev investment will be worth more.